Look at some conversions. These are not hard. Remember, we've got this, I call it the little molar road or whatever, but we generally go from like mass in grams to moles, or from moles to molecules, or we can go this way. We can go molecules to moles, or we can go from moles to mass. So if you're going from mass to moles or moles to mass, you have to calculate your GMW, or your molar mass. If you're going from moles to molecules or atoms, whatever the case is, or molecules back to moles, you have to have Avogadro's number. 6.02 times 10 to the 23rd is Avogadro's number. Now for this final, and to be honest with you, we do need to know how to count how many molecules and how many atoms we have. But in real life, most of the time, we're focusing on going back and forth from grams to moles. Okay, this is where the big, you'll get the big bang for your buck. So when you're studying for this final, I want to make sure you can go back and forth. So let's take this problem, convert 17 grams of ammonium nitrate to moles. So we're starting with grams. Okay, that's our given. And this is what we want, is moles. That means we have to know the GMW. So I'm going to knock that out because I need to know it. So ammonium nitrate, we've got the formula for that is NH4NO3. Okay, so nitrogen, I have one of them times 14 grams per mole. Hydrogen, I've got 4 of them times 1 gram per mole. I have this nitrogen here, so I lied to you. I've got 2 nitrogens, so I'll just do it separate. One of them here, but I could have said 2 times 14 to give me 28 up here. I just wasn't thinking, which generally happens when you've been at work past 12 hours, or if you're kind of empty-headed like I am, and when you combine empty-headedness plus being at work past 12 hours, then you get like really, I don't even know what I'm doing anymore. Okay, but I think you can trust me here. Okay, 14. So 14 there. But I could have said 2 times 14 gave me 28. I could have done that, but I just wasn't thinking. Oxygen, I've got 3 of them times 16, and I believe that gives me 48. So you add all these things together, and since I'm so empty-headed and tired at this point, I'm making sure I'm using my calculator. So 3 times 16 does indeed give me 48. I'm going to add 14 plus 4 plus another 14, so 80 grams per mole. I know I'm going to need that somewhere. Okay, so now I'm going to start with what I'm given. I'm given 17 grams. And when you use dimensional analysis, you don't even have to think, do I add, subtract, multiply, divide? You don't have to think about that stuff. All you do is you've got to cancel grams to end up with moles. So to cancel grams, you're going to have to flip that and put the 80 grams on bottom and put the mole on top so that your grams cancel and you end up with moles. Okay, so when you're going from mass to moles, you're going to, divide by the GMW. But it's easier just to do it this way so that it's visual and you check what you're doing. So 17 is on top, 80 is on the bottom, so that means you're going to say 17 divided by 80, and that gives you 0.2125. Okay, so 0.2125 moles. Now let's take a look at this one. This next one says that we're going to convert from moles to grams. Well, if we multiplied going from grams to moles, we're going to divide going the other way. But I don't want to trust that. I'm taking a test and I'm stressed out, so I want to use dimensional analysis to make sure I'm getting it right. So sulfuric acid is H2SO4. So hydrogens, I've got 2 times 1 gives me 2. Sulfur, I've got one of those times 32 grams per mole. Oxygen, I've got 4 times 16 is going to give me 64. So that should add up to 98, 248, 98, yeah, grams per mole. So now in this, I'm going to start with what I'm given, which is 2.7 moles. I put that over 1. I want to cancel my moles and end up with grams because that's what I want. So in this case, I do not have to flip it because grams is on top. So I'm going to say 98 grams over moles. Moles cancels. And since both of these numbers are on the top, I'm going to multiply them. So I'm going to say 2.7 times 98, and I get 264.6 grams.